Good evening, all. Welcome to One Mark Solution. Please subscribe, like, and share to your friends. Let us continue with our current electricity, the case study. So, we have completed the assertion and reason. Now, the case study. I think you know that in our board exam, the case study is also included, and 5 questions will be there. Out of the 5 questions, we have to write 4 questions, and each question having 1 mark. So actually, it is also included in 1 mark solution. Now, let us start with the first one. Resistance value of unknown resistor is calculated using the formula R is equal to V by I. And this equation is very, very important. Why? Because all of you know that Ohm's law comprises this equation. Whenever we are hearing about the Ohm's law, we can say that V is equal to I into R, where V and I are the readings of the voltmeter and the ammeter. R is the resistance. Resistance means resistance to the flow of current. Now we can see the 2 circuits given below. Consider the circuits, the first and the second, which is marked as A and B. The internal resistance of the voltmeter and the ammeter are finite and non-zero value. And the internal resistance of the voltmeter, we can call it as RV, and the ammeter, we can call it as RG. Here it is given like that, respectively. We can say RV and RG. And we can observe the figure. In the figure, you can say a resistance R is connected parallel to the voltmeter. Always voltmeter is connected parallel and ammeter is connected in series. That also you can see here. Why voltmeter is connected in parallel? To measure the voltage. And you know that, all of you know that, in parallel combination, voltage remains constant. And that is why in household appliances, we are using parallel connection. So all the devices will get the same voltage. And here also we can say the ammeter. Ammeter is connected in series. Why? Because always in series combination, current remains constant. And in household appliances, again, we can say the device and the switch we are connecting in series. Whenever you need any device to work on, you can switch on it. That is why it is connected in series. Here, RA and RB be the calculated values in the 2 cases, A and B respectively. That means RA is the resistance in the case of the first circuit and RB is in the value. That means RB is the total resistance in the second circuit. So that is a figure. First of all, you have to observe it. Now we can go for the questions based upon this data. So the first question we can say, the relation between RA and the actual value of R. Here you can see the figure. Once again, I'm just showing that the figure R and we can say the total resistance RA. Which one will be greater? You can see that first of all, we can just see I have written there RA is equal to, how will you find RA? You can see that it is parallel combination. R and voltmeter is in the parallel combination. So first of all, you have to find the resistance of the parallel combination. How will you find the parallel combination? 1 by R1 plus 1 by R2 is equal to 1 by R. So we can say that if you are simplifying it, you will get R1 R2 divided by R1 plus R2. Here also we have written R into RV divided by R plus RV. That means you can see the figure again. Here it is parallel. So that is why here we have written 1 by R plus 1 by V and we have to take the reciprocal. So here I have written R is equal to R into RV divided by R plus RV. And in the parallel combination, always the resistance will be less and in series resistance will be more. So here the options we will read it. So you'll get the answer from that. R is greater than RA. Yes or no, you can just think it off. R is less than RA. R is equal to RA and dependent on E and R. No, the fourth option is not there. So which is the options? From it is very clear that RA is less than R. So it is not written here. It is written in the reverse manner. So which is the option? Don't get confused. The simple you have to make it clear. So which is the answer? The option A. We can say R is very much greater than RA, or in the reverse also you can write. So here the answer is A. Now we can go for the second question. The relation between RB and the actual value of R. See the figure. I will just show the figure again. So here we can say R and A. You can see it is in series combination. So when these two are combining, that means in series combination, we can say we will just add it together. So here what is the option? It will be RB will be greater than R, isn't it? That means RB will be greater than R, or we can say R is less than RB. So the option A will be the answer. In the previous case, it is parallel combination. Here it is in the series combination. So the option is absolutely the first one, that is A. Now we can go for the third question based upon this. If the resistance of the voltmeter is RV is equal to 1 kilo, they are giving the value of the voltmeter, that is resistance of the voltmeter as 1 kilo. And all of you know that voltmeter is having more resistance. 1 kilo means 1 into 10 raised to 3. And that of ammeter is Rg is equal to 1 ohm. The magnitude of percentage error in the measurement of R. We have to find the percentage error. And last year you have studied the percentage error. That means the difference in value of the resistance divided by the original resistance into 100. That will be the percentage error in the measurement. That is delta R divided by R into 100. That is a formula. We can use it. So the value of R also is given as nearly 10 ohm. So we can find the percentage also. So first of all, we have to find the delta R. Here it is written there, RV by R plus RV minus 1. Why? Because we know that the combination is parallel. That is why we have written like that. So that into 100. Delta R, that into 100 divided by R is also there. Then what else we have to do? We can say that R plus RV, when it go R, we can say that it will cancel, and the last equation, when we are simplifying, you will get it R by R plus RV into 100. And the value of R is given here, that is 10. Divided by R plus RV is also there. RV, what is it? 1 into 10 raised to 3. That means 10 raised to 3. And R is also given as 10 ohm. So when you are doing it, you will get almost cancelled. We can't say it's so cancelled. Almost it is cancelled. And we will get the 1%. So in the case of the first figure, we are getting 1%. The first figure, we can say we are getting 1%. That means the voltmeter is parallel connected to the resistance. Then we'll go for the second case. Why? Because we want to find in which case the percentage error is more. Similarly, we can do the second case. What will be in the second case? We can say RB. There it is RA, here RB minus R divided by R into 100. And we can just substitute for that. That is RG divided by R into 100. RG, what is RG here? 1 ohm. And divided by R, what is R? 10 ohm. So 1 by 10 into 100. 1 by 10 into 100 means 0, 0 cancel. What will be the answer? 10%. Please simplify it with this formula. The formula is very simple. Delta R by R into 100. You will get both, and the values are given. Is also here. So which one is more? We can say in the circuit A or B. No doubt it is in the circuit B. So the option B. I think it's clear to you, children. Now we can go for the fourth question. When resistors are connected in parallel, effective resistance will be. In this case study, we have made a conclusion. We already know that resistance in series and parallel. We can say that when they are connected in parallel, always, what will be the answer? Less than the least resistance. It will be less, not only less, we can say it will be less than the least resistance. Usually, when we are discussing to the students, we will say, we will take 1, 2, 3 and we will add it in the parallel combination. So 1 by 1 plus 1 by 2 plus 1 by 3 we are getting. So we can see that it will be always less than the 1. 1 means 1, 2, 3 out of 1, 2, 3, it will least will be 1. And what will be the answer? 1 by R is equal to 1 by 1 plus 1 by 2 plus 1 by 3. So the answer will be 1 by R is equal to, we can say 6 by 11. And you just think it of 1 by R is equal to, we have to just add it out, We will get the answer 11 by 6 and take the reciprocal of R. That means we have to take the reciprocal, then only we'll get the answer. So R is equal to, we can say 6 by 11. You will get the answer 11 by 6, 1 by R. But R is equal to, we can say it is 6 by 11. It is less than that of 1. That is an example only. So here we can say always it is less than that of the least resistance, we can say. So the answer will be, no need of going through that. We can say the options, so many as given here, but the correct answer we can say option A, that is less than the least resistance. Now we can go for the fifth question. Internal resistance depends on. Internal resistance is also very important. Internal resistance depends on 4 factors. You already have studied it. The length of the electrode, no. Length, it does not depend. Nature and concentration of electrolyte, absolutely correct. Why? Because through the electrolyte only the current is flowing, the ions are flowing. So anyway, the nature and concentration of electrolyte will be there. That is one of the dependence of the internal resistance. Then area of connecting wires, no. Connecting wires, no chance. Then none of this. So the answer is the option B, nature and concentration of the electrolyte. Now, I think some idea you got it, I think. Children, thank you for watching and please subscribe, like and share it. Thank you.